Pandas, NumPy, top tips, visualization and more. Stay tuned for this data analysis project that will land you your dream job. I'm going to take you step by step to downloading the data, importing it into Python. We'll clean it, look at missing values, visualizations, we'll group the data and perform some calculations, and at the end, you'll have a stunning and impressive portfolio project that will help you land your dream analyst job. Let's get right into it. I'm currently in my Jupyter Notebook environment. I'd recommend you use this. Although, however you use Python, use that. What we're going to do is go to kaggle.com. It's a brilliant site for data science to get various data sets. Here's the link. This is global country information for 2023. What I want you to do is take a look at it, the key features, really understand this data, and I will be linking this below. You can even look at other people's code to get inspiration, and then come to the top and hit download. It'll ask you to sign in, so make sure you have an account. Once downloaded, this should be stored in a zip file. Make sure to open it up and put it in the same location as your notebook is stored. Then we can get into the project. What we're going to do today is some global data analysis, which will explore various factors and look into the insights and relationships between birth rates, fertility rates, infant mortality, life expectancy, physician availability, and even population across these different countries. What I'd recommend you do is at the beginning of your portfolio, you write a little bit about what you'll be doing and why, what skills you've demonstrated. We'll want to import our necessary libraries, being Pandas, NumPy, Matplotlib and Seaborn. I have created separate educational tutorials on each of these to walk through in depth what they are and how they work. But for now, let's just import these for later use. Then I'll hit run. Fantastic, everything has gone smoothly. With these, I'll be able to manipulate the data frame, run numeric computations and visualizations. Now, I know the name of the CSV, I've got it stored here. Let's open this up into a Pandas data frame, like this. df or data frame is equal to pd pandas dot. Fantastic. We want to check this has worked, so I'll load the head or the first few rows of the data frame. Now this will always be the first 5 rows. You can change that by writing a value here. Now it's the first 10. What I can see by this is all the different columns and rows for these first 10 rows. There are 35 columns and 10 rows. Now what I can see is there's many different values here. There's a real rich data set with a lot to explore, which goes over a variety of different countries, locations, and various different details about those countries, such as the CO2 emission and otherwise. What I'd always recommend doing is exploring the shape of the data frame. Simply. And what this will do is tell you that whilst there are 35 columns, in total there are 195 rows. Armed with this information, we can get into the data cleaning and preparation. I would also recommend looking at the info of the data frame, but we'll get to that shortly. So since there are 35 columns, I want to reduce this data set and I want to clean a subset. This is something that's commonly used in our analysis. I want to look at a certain few features. So if I type in df.columns, I can see all the various columns available to me rather than having to scroll up and looking back and forth between here. We'll get it as a list. There's quite a few. Now I'll update the data frame. I could assign it to a different one entirely, but I'll just call it df is equal to data frame. And then each column I want to see inside a single quotation mark, separated by a comma. So I've gone through this previously and I know I want to look at country for the comparison, birth rate, fertility rate, infant mortality, life expectancy, physicians per thousand, and population. Now, with this subset, I can look at the info with df.info. What I can see from this is how many null values there are. What is the data type? And do we have the correct columns? And I can see we absolutely do. Now, there were some missing values. As you can see here, I've outlined in the following areas, there were missing values. Interestingly, population down here was an object. Why was that? Well, I came to the conclusion that due to the presence of commas in the numbers, that had meant it wasn't stored as an integer. So let's do something about it. First of all, within the data frame in the population column, I want to change this to a string rather than just an object. So I'm actually changing it to words, textual data. Why am I doing that? Well, I'm doing it so I can replace the commas with nothing. Once I've changed it to a string, I can then replace commas with nothing. From there, I'm able to convert the population to a numeric value, and I do this like that. You can see here I've done the population column and to numeric, but I've written something here called errors equals coarse. What does that mean? This just means that anything that cannot be converted to a numeric data type will be made a null value. Very handy. It's more of just handling our errors. Fantastic. And there we go. Before we go any further, let's just see what we've done here. We have imported the data, taken a look at the head, we've cleaned it, made a subset, explored the information of that data, and we've already identified some elements or errors within our data set. This is brilliant work and will look very impressive in your portfolio. We are getting quite advanced with the work here, but I'll walk you through step by step. The next thing I wanted to do was really handle those missing values. So for each of those columns within the data frame, what I did was calculate the median value. And then when there was a null value, I filled it with the median of those columns. We can hit run. Again, we're getting into the more complex side of Python here, and I really wouldn't worry too much if this is too confusing. What I want to do next is rename some of these columns. I didn't like that in some cases there were spaces, and other cases capitalization, and others there weren't. So for consistency, again with Pandas, I did df.rename columns birth rate to birth rate with an underscore. In place equals true. Now again, in place equals true means that when I run this, it won't only be the case for this cell, but for all the subsequent cells as well. Every time I run this, it's a permanent change. Infant mortality, we've also capitalized the M, life expectancy, and physicians per 1,000. Then I'm going to run df.columns just to check this has worked. Perfect. That has worked exactly as we required. We've done the data cleaning, and now we can get into the visualizations using Seaborn and Matplotlib. The first thing I typically start with in these sorts of projects is displaying pair plots to explore correlations between and across the data frame. Very easy to do this. If you recall, we stored Seaborn as SNS. So SNS.pairplot. And we'll run this across the entire data frame. When I hit run, it'll take a few seconds typically, particularly with the vast amount of data we have here, 35 columns. So that's something just to bear in mind. Let's have a look at this now. You can see some really strong positive correlations between various different elements in the data frame. For example, birth rate, of course, if we go down, and fertility rate are very strongly and positively correlated, whereas life expectancy and infant mortality are negatively correlated. This is really interesting and gives us an initial insight into the relationship between these variables. And what we want to do is explore this further, go deeper. We can do that with the correlation matrix Heatmap, another very impressive element using Seaborn, but then also Matplotlib here, we're changing the title and the figure size for your portfolio project. We're going to create our df.core correlations matrix and assign it to the variable correlation matrix. Now, What I had done is when I made this, I realized it looked a little bit off. So I changed the figure size here to 10 by 8. So Seaborn.heatmap, using this correlation matrix, which runs across the entire data frame. And not equals true, meaning that it will display the numeric values on top of it. And CMap equals cool warm, taking it from red to blue. Then we gave it a title. Now, 1 would be fully correlated and -1 would be no correlation at all. In fact, it's a negative correlation. We can see everything is 100% correlated with itself, going down diagonally. But where we get interesting is the other elements. 0.87 infant mortality and birth rate. Interesting. Whereas population and physicians per 1,000, not so strong. This is really where you can begin to shine in your project. Say why you think this might be, and then test those ideas. We're going to run through a few more visualizations here before getting some hard calculations and groupings to test those. And at the end, what I'd recommend you do is write a conclusion, a paragraph, a closing statement to say what you found, what you did, and why you did it that way. What would you improve? These are things that hiring managers will really want to see that you understand the data. You haven't just copied it from a video such as this. You actually have a deep understanding of why you've done what you've done. So I want to display a distribution histograms for each of the columns. Again, I've changed the figure size. But then I've run a bit of a code here using subplots. And again, for all these different visualizations, calculations, and so forth, you actually don't have to use these specific ones I've done. What I'd recommend you do is create visualizations of your own. Really experiment, make this yours and personalize it. Now, I created some subplots here, and it's a bit of complex code. We'll skim over this, and if you'd like to really understand it in depth, take a closer look. But again, really it's just looking at the distribution by each of these relationships. Something a bit more simplistic here, again very powerful, is a scatter plot for the birth rate versus life expectancy. Again, we changed the figure size. We use the data as the data frame, the X variable being birth rate, and Y life expectancy. Then we made the title what we required. Hitting run here, fantastic. We can see that as birth rate goes up, life expectancy goes down. Now this might seem quite contradictory. Why might this be? It's an interesting point to explore and might require further analysis and exploration. Let's take a look here. I wanted to display the top 10 countries with the highest population. So I created a variable called top population countries and set it to the nth largest, 10, in the population column. Then I just set up the style and the context for the plot as white grid and the size. And I simply made a bar plot where our X variable was the country and by Y was the population. The data was this top population countries, which is referencing our data frame. I customized the plot with the various labels and titles, and I also rotated the axis for easy visibility. Let's hit run. There. You can see here the axis of the labels are rotated so that they didn't overlap. We have our different labels and titles, and I particularly like the color scheme and layout. It very clearly lays out that China is the highest population. Japan is the lowest within the top 10. But what if I wanted to explore by two different variables? For example, the average fertility rate by country. To do this, you'd use Pandas. And I've explored this extensively in my previous Pandas video. But what we do here is a group by calculation. The average fertility by currency is our variable name here, was equal to the data frame group by country and fertility rate looking at the mean. When you break it down here, really just within our data frame, we're grouping country and fertility rate and looking at the average. That's all we're doing. What if I wanted the nth largest for the top 5, highest life expectancies, grouping life expectancy and country? We can do that too. What about the lowest? Again, and smallest. This works as well. We're getting to the end here, but what I'd highly recommend is you explore not only this dataset, but Kaggle as a whole. See what datasets there are now. See what you can do with it. Use ChatGPT AI. Use various resources and create a project that can demonstrate all of these skills. I find that when I'm watching these videos, I try to exactly copy each line of code, even if it's something I'm not familiar with. What I'd recommend you do is try writing this out yourself. Try different visualizations, different group bys, maybe even use a different data set entirely. The core principles should remain the same. Now, good luck and all the best.